Good morning, everybody. Today we discussed about the very important furnace used in manufacturing industries. That's particularly in foundry, the conventional method and large quantities of cast iron can be easily produced by using cupola furnace. And the Bhadravati VISL is the famous foundry throughout the world. Say, if you go to 30 years or 40 years back, the cast iron made in the VISL is the greatest quality and throughout the world, which was very famous. But unfortunately, the VISL is closed. So if we visit the VISL, I make you to see the cupola and also you can enter inside the cupola. Enter inside the cupola and see the different zones in the cupola. So this is the very economical, easy, and you can produce large quantities of cast iron. Large quantities of cast iron. To the examination point of view, this is very important, and also for mechanical engineers, without the cupola studies, you will not become the mechanical engineer. Wherever you go for any manufacturing industry, they ask you to the question, which method is convenient, easy, and the production of large quantities of cast iron. The only method, the cupola furnace. You can produce maximum millions tons of cast iron is possible. So you can run the cupola 3 years, 5 years, 10 years. There will be example of still running cupolas in some of the German companies. They are running from past to 25 years. So continuously you can produce the cast iron. That is the advantage of using cupola. And all of you please write down the question. Explain briefly the principle of operation of cupola furnace with the neat sketch. And the next line, write down one more question, the same question in different way. That's write down. Explain briefly with neat sketch the different zones of cupola. So on the right side, all of you observe, there will be 4 zones, very important one, starting from the bottom: combustion zone, reducing zone, melting zone, and preheating zone. So these are very important. Next, we come to the point how the cupola is constructed using the steel shell, refractory lining, and all the construction explanation. Next, working. Once you charge melting of the cupola, it will be continuous. And charging of cupola, there will be 3 charges. One is metal, other one is flux. Flux is nothing but the calcium carbonate or limestone, and flux is the calcium carbonate or limestone, and the coke is readily available. Singarani Lignite company which supplies the coke. By layer they place the metal charge, flux, and the coke on the according to the ratio. Usually 30-30-40. Remember, in your lifetime, the 30% of metal, 30% of flux, and 40% of coke. Usually 30-30-30-40. Next, this is the charging of cupola. And next, melting. The melting, once you start burning of metal inside the cupola, it will be continuous for 3 years, 4 years, or even 10 years. Next, come to the point. This is the charging. How you can charge the cupola. Next, after completion of melting, the observer or the operator see the metal in color. Usually, the color of the cast iron is yellowish orange. Remember, in the screen, you can see the yellow color and the orange color. you can see the yellow and orange color. Actually, it is red color. When the metal turns to yellowish orange color, then the operator by his experience, he said that the melting temperature, the temperature of the liquid metal is 1350 degrees to 1400 degrees centigrade, and the metal is ready for pouring. Next, drop down button. Usually, the waste material are coming along with the flux, along with the metal, along with the coke that is melted and forms the layer that is called slag. That is called slag. Usually, the slag floats on the surface of the liquid metal that can be removed. That can be removed from the dropping down door, which is present at the bottom. Next, come to the point. The zones, different zones of cupola. There will be 4 zones are present. One is well zone. This is placed near the tuers. In the tuer, they supply the high pressure air. Next, combustion zone. Here, the combustion zone, which is actually, it is called oxidizing zone also, because the coke melts, and along with the melting of coke, which melts the metal, scrap, iron ore under the flux and forms the cast iron. Usually in this zone, the temperature ranges from 1550 degrees centigrade to 1850 degrees centigrade. Next, come to the point, reducing zone. So here is the protection zone, and also which is below the combustion zone, carbon dioxide gas moving upward direction, and coke get reduced to carbon dioxide to carbon monoxide. Remember, all of you, the reduction zone means the formation of carbon dioxide is always present while converting the metal into cast iron. The carbon dioxide released in the reaction. When the carbon dioxide moves upward direction, there will be reduction of gas takes place. This carbon dioxide reduced into carbon monoxide, CO, carbon monoxide. The temperature of this zone is 1200 degrees centigrade. See, all of you observe here, instead of releasing the carbon monoxide to the atmosphere, it has the temperature of 900 to 1000 degrees centigrade, or even sometimes 1200 degrees centigrade. So this much of heat of the gas, which is utilized for heating of the metal, coke, and the flux. So that gas is utilized for heating of the raw material, that is metal, flux, and the coke. That is called preheating zone. So in the examination, you have a question. Explain briefly different zones of cupola. So for that question, you have to write well zone, combustion zone, reduction zone, reducing zone or reduction zone, and preheating zone. Next, come to the point. Again, green sand molds. All of you write down the green sand molds. So this is the simple, easy, and you can produce the casting economically. Remember, you can produce the casting economically. And the important thing is the skill, experience is not required, because you can work, anybody, the ordinary operator or ordinary worker can work on the sand molds. All of you come to this. See the green sand molds, underline that, write down the sand molds, a colon, write down green sand molds. First, come to the point. The pattern is placed on the bottom board on which the grants 5 to 7% of and 5% of water and remaining river bed sand. Place the pattern on the board, cover the pattern with the tag of the mold box, and fill the mold box with the green sand. Then turn the box upward direction. The pattern which is coming upward direction in the top. You remove the pattern from the sand mold, and next place the cope on the drag, and place the screw and riser. Screw for pouring the molten metal, riser for in order to compensate the volume contraction. And as soon as if you pour the liquid metal in the screw, which fills the mold cavity, the same time which fills the riser, and due to capillary action, remember.
ಸರ್ ವಾಯ್ಸ್ ಏನು ಕೇಳಿಸ್ತಾ ಇಲ್ಲ ಸರ್. ಏನ್ರ ಸರ್ರೇ ಹೋಗ್ಬಿಟ್ರು.
Hello.
Pratik? Anybody else?
Nutan, sir.
Now, Nutan, screen is visible and audible, no?
No, sir.
No, sir.
Screen is not visible.
Not, sir. No, sir.
Now,
ಹಾ ಸರ್, ಈಗ ಸರ್ ಕಾಣಿಸ್ತಾ ಇದೆ.
ಕಾಣಿಸ್ತಾ ಇದೆಯಾ? ಹಾ.